Hello, welcome to Zonal Academy. In this video, we discuss dimensional equations for derived physical quantities. In the previous videos, we looked at a physical quantity and the two types of physical quantities. And we mentioned that there are two types of physical quantities, and those are fundamental physical quantities and derived physical quantities. And derived physical quantities are just quantities that are derived from the three fundamental quantities, which are mass, time, and length. And so in this video, we discuss the dimensions of these physical derived quantities. And when we talk about dimensions of a physical quantity, we are just basically discussing the physical nature or the form of that quantity. Basically, what we are looking at is of what type of physical fundamental quantities are these derived quantities made of from the three fundamental quantities, which are mass, time, and length. So we're just looking at the physical form or the physical nature of that quantity. For example, if we discuss a derived physical quantity such as distance, you know that distance can be measured using different units. Distance can be measured in meters. It can also be measured in miles. It can also be measured in feet. But whatever units that you use to measure distance, whether distance is measured in meters, whether distance is measured in miles, or distance is measured in feet, what you're trying to measure at the end is just the distance. So distance, whether in meters, in miles, or in feet, is still distance. But you also know that when measuring a distance, you're just basically trying to measure the length. So whatever distance you're trying to measure, all in all, you're trying to measure the length. In other words, this simply means that the physical nature or the physical form of this derived physical quantity distance is the length. And this is to say that the dimensions of distance as a derived physical quantity is just length. In other words, distance is formed by is formed from this fundamental quantity length. So the dimensions of distance are just length, describing the physical nature of a distance. And so when we talk about dimensional equations for these derived physical quantities, we are just basically looking at fundamental equations that relates these derived physical quantities to the units of their fundamental quantities. As already stated, we know that derived quantities are just made from fundamental quantities, and so they obtain the very units of their fundamental quantities. That is to say, for example, the distance, as the example that we have taken, we know that distance is just made or derived from length as a fundamental quantity, and we know that length is just measured in meters. Therefore, distance as a derived quantity will inherit the units of its fundamental quantity, which is just length. So length is measured in meters. Therefore, because distance has the dimensions of length, distance is also measured in meters. So dimensional equations basically are just fundamental equations that will relate the derived physical quantity to the units of its fundamental quantities, which in this case is just length, and so on and so forth. Now, as we discuss dimensions, let us look at how we express the dimensions of a physical quantity, and let us look at a few examples. So let's look at the notation and a few examples of dimensions. So the fundamental physical quantities, as already discussed, we have mass, we have time, and we have length. So how do we express the dimensions of these? So if we know how to express the dimensions of this, then it becomes easy to know how to express the dimensions of the derived physical quantities, because the derived physical quantities are just derived from these fundamental units. So if we want to express the dimensions of mass, we know that mass is a fundamental quantity, so it cannot be expressed in any other quantity apart from mass itself. So the dimensions of mass will just be given by capital letter M. So the notation that we use in expressing dimensions is just by using brackets. So we put inside of the brackets the physical quantity that whose dimensions we want to express. So brackets show the dimensions of the physical quantity. So like in this case, if we want to say dimensions of mass, we just put mass, the symbol M, inside of those brackets, and this is just shown by capital letter M. And if we want to express dimensions of time, so small letter t to symbolize time, are just given by capital letter T. And dimensions of length, small letter L, are just given by capital letter L. So these brackets are just there to denote or to note that these are dimensions of length. So dimensions of length are just given by capital letter L. Dimensions of time are just given by capital letter T. Dimensions of mass are just given by capital letter M. Now, our main focus is to look at the dimensions of derived physical quantities. So the dimensions of the derived physical quantities will also be based on the three fundamental quantities. Remember that derived quantities could either be made directly from just one of these, or maybe a combination of two, or a combination of all the three fundamental quantities. So let us take a few examples of derived quantities. So let's look at examples of derived quantities. Let us begin by first looking at, for example, velocity. We know that velocity by definition is just the distance over the time as known. So if you want to express the dimensions of velocity, so we'll just say dimensions of velocity will be given by the dimensions of time, of distance, divided by the dimensions of time. And we know that the dimensions of distance are just capital letter L, and dimensions of time are capital letter T. Therefore, the dimensions of velocity will just be given by L over T. So this is how you express the dimensions of velocity. Velocity is a derived quantity that is made from length or derived from length and time. So if we take another example, maybe we take, for example, force. We know that force is just given by mass times acceleration. Therefore, if we want to express the dimensions of force, we'll just say dimensions of force are given by dimensions of mass and dimensions of acceleration. And we know that acceleration is just given by velocity over the time. So this simply means the dimensions of velocity are just L over T and divided by capital letter T. So this simply means dimensions of force are given by dimensions of mass, which is just capital letter M, and dimensions of acceleration, which is just L over T squared. Therefore, these will be the dimensions of a force. And we could go on and on by looking at other examples. Maybe if we look at volume, we know that volume is just given by L times L times L. So the dimensions of volume will just be dimensions of length, dimensions of length, dimensions of length. Therefore, the dimensions of volume will just be given by capital letter L multiplied by L by L by L. So this will just be L cubed. And we could go on and on looking at different examples. So this is how we express, this is how we denote dimensions of a derived physical quantity. In the next video, we shall look at how we use these concepts to check the correctness of the equation and also to derive equations using the concepts of dimensions.